Okay, so hello friends. In this session, we are going to do one more activity related to DSA tools. Okay, so I'm so till now you're familiar with the basic functionalities of these tools: ESAT, SAT, DSAT. In this case, in this particular experiment or session, we are going to learn how to design and develop our user-defined models. Okay. In particular, in this case, we'll be developing a special protection scheme using something called UDM editor. The DSA tools allows us to come up with our own logic, own user-defined function. So how to do that? Because once we learn this, then it can be taken into any particular system to develop any control schemes, protection schemes, whatever is required. Okay, so this is the agenda: design and development of special protection scheme using UDM editor module. Where is that UDM editor module? You can go to start button and just type your UDM. You can see UDM editor is there. Okay, so the test system we'll consider is the IEEE 9-bus test system as shown here. So here you can see there are three machines which are in operation: G1, G2, and G3. And this particular system, or for this particular system, we're going to develop a special protection scheme. Correct. So what exactly we're going to do before we go to the actual function? What is SPS? So in our last semester, we discussed about various protection philosophies, and for different equipments, lines, transformers, isn't it? But then there is something called special protection scheme. Otherwise, some people also use this term called SIPS, System Integrity Protection Scheme, where it is essentially system level protection, right? It is essentially system level protection. You don't want your system to go into the unstable region. You don't want some of the machines to go out of step because of some contingencies. That's where this type of philosophies are used. Okay? That's why the name is also special protection scheme. So for this system, what we're going to do, uh, we are going to pick this particular generator G2 when two conditions are met. What are they? This megawatt flow through the line 7-8 is more than 100 megawatt. That is the first condition. And line 5-7 is stripped. Right. So this line is stripped and the flow through this line is more than 100 megawatt. Then I'm asking the uh, control or protection to strip this particular generator G2. Again, the objective is not to showcase how the special protection scheme will save the system. Rather, the objective is to make you learn how to come up with our own user-defined logic using DSA. Okay. So what you need to do, we'll follow all the steps. Start UDM editor, which I have already done. Go to select file, new UDM model. So go to file, new UDM model. By default, it's a dynamic model for TSAT or SSAT, and you need to identify device using bus number. Click on OK. Right. So this is what I do. Then you go to select model, see model library. Go to model, AC model library. Then select a device. Click on system protection scheme. Again, DSA provides different types of system protection schemes, templates for different types of system protection schemes. You just click on out of step tripping brilliant. Sorry, you click on transfer tripping. Okay. Uh, then click on OK. It will ask you to provide some ID, so you can type A1 for example, anything you can give, and then click OK. Right. So go back to our manual. So this is what I have done. Step number 5 is done, 6 is done. Select transfer clip and click OK. Already that is done, and this is what you are seeing, right? And already I have given the SPS ID also. Correct. Now we need to add our logic. Okay. So double click on the top branch status block to edit its properties. So branch status, you can see, just double click here. So here I need to provide the tripping logic. So what I said, I need to monitor when line 57 is tripping, correct? So you just make the status as tripped, and block name you can give anything, PLK 7557. From bus you can give letters as 7 to 5. Okay, click on OK. Already that's what I have mentioned, right? Then you delete the blocks highlighted in red. These 3 blocks you just simply remove, because for this logic you don't need. Remove this one, uh, this one, this one, correct? Uh, then add a link between the branch strip block and the AND block. So branch strip block you have already created. This is where you will get the link. Just connect this one with block. Okay. That means that is the first condition we could implement. So this forms the logic to detect the loss of circuit during simulation, correct? So if in the DSA dynamic file you are tripping this particular line, so this will be first logic that you are satisfying, and that's how in the user-defined model you have incorporated that logic, right? Delete the generator active power block, point number 14. So go back, generator active power block, you can delete. Then you need to bring the interface monitoring block, because you need to monitor the flow through the line 7-8, correct? So go to the input monitoring, and then there is something called interface. So you just bring this one, then block name anything you can give, add the interface, which interface you want to monitor, from bus number 7 to bus number 8, and the ID is 1. You can cross check these numbers once you have the TSAT file with you. These files will be given to you, so you can directly import the 90 bus system. Okay. Variable you want to monitor is P in megawatt. Click OK. So now this second logic is also written. Okay, go back to the manual. Then what you need to do, you have already edited the properties, right? Then add an initial value block to the interface. So go back to the UDM editor. So initial value block will be there in control, under the control block. Okay, just bring that one, right? And then what else? Add link between the interface, initial value, and greater than block. So you need to include this particular link into the interface. So again, go to the link, connect this logic. Okay. Then interface block will be greater than symbol. Okay, because you want to monitor this flow, and then you want to compare if it is greater than 100. So just change the value, gain value to 100, right? So we are done with point number 18. Then this is almost done. Edit the trip generator. So if these conditions are met, you are saying that you need to trip which generator, bus number 2, generator at bus number 2. Okay, so we go back, and again block name anything you can give, bus number you click 2, ID number will be 1. Delay time you can control whether you want to trip after 3 cycles, 100 cycles, it is up to you. Okay, so click on OK, right? Then go back. Then your UDM is now ready. So this model will be saved in the .dat format. Okay, you can save this model. Also go to file, save this one. So already I have saved. I need not save it again. So you can save it in a folder, and then you need to open the tsat file of 9-bus system. Okay, and then include the dat file in the dynamic data. So go to tsat. Okay, we are already familiar with tsat. So open the tsat file for 9-bus. So 9-bus, you can see .dsa. You just click here and open this one. So in the dynamic data, you need to import this particular data file. So already I have imported, but how? Let us see if it's not there. You can browse and include this data file. Okay. And anyway, dynamic file will be already there. DY file will be already there, right? So everything is done. So I will just run this case, okay, to demonstrate how it works. Is there anything else we are missing? No, yeah, rerun. Okay, so I hope you can see. Uh, I ran the case. Okay, so you go to the view results section. Okay, so you can see so line 57 trip is the contingency. So I need to first check two conditions. What are they? First, whether line 57 is tripping or not. So line active power flow you can monitor. So click there and selected quantities. So you can see if it is tripping. Yes, it is tripping at 5 seconds because that's how I have defined the contingency. It is tripping at 5 seconds. Okay, it is tripping at 5 seconds. Then the next thing I need to check is whether the flow through line 78 is uh, greater than 100 megawatt or correct. So go to line 78 flow. Yeah. So you can see once the contingency happened, your flow crossed 100 megawatt. So at this instant of time, you are triggering the special protection scheme, and then based on the delay, the generator will be tripped. Okay. Let us see the generator tripped or not. Go to the generator active power flow. Click there. So I am supposed to trip generator 2. So monitor the generator 2. Yes, you can see after the specified delay. I think in this case the delay is more. I'll go back to this thing, but anyway, this is stripping, correct? This is stripping. You can see this is stripping after the specified delay. So let me go back to the contingency to see what is the delay being provided. So you can play around with the delay after how much time you want to uh, trip the generator. Okay. Yeah, it is 200 seconds cycles. Okay, you can make it three cycles. Let us will make it. Let us make it 3 cycles. Okay, and then save it, and then rerun the contingency. So you'll see that once the condition is made, the generator is stripping within 3 cycles. Okay, so go back to the results. Go back to the contingency 9 clip. Go back to the generator active power. So now you can see very quickly it's stripping. Isn't it? Very quickly. Very quick. Within 3 cycles, it is happening. Okay. See, again, I'm reiterating myself. The objective of this activity is not to showcase how the SPS would save your system. No, because that's something which you can explore the system and see what are the contingencies leading to insecure zones. Then you plan for the special protection scheme. The logic or the objective of this activity is to make you learn how we can develop your own user defined logic and integrate it into your system, right? Yeah, I think that's where we'll stop. You can try this particular activity. Thank you for it.